If planets are smashing together in other systems, they probably smash together in our own. We now know that all solar systems do this before they settle down. It's the way they're built.
The nice, neat, orderly solar system that we see today has not always been the case. In the early days, a few million years basically after the planet started forming, there were dozens, maybe even hundreds of these young planets that were bouncing around the solar system. They would smash into each other. Sometimes they would collect and get to be bigger planets. Sometimes they would smash each other and turn into little bits.
There was heavy traffic in the new solar system. Objects of all sizes. They were bound to collide. Some of the planets grew larger, and so did the collisions.
I'd like to try to imagine what it would have been like to actually stand on the early Earth and look up into the night sky. Things would have looked different.
Planet hit planet. Only the largest survived. The rest were smashed to pieces. Something very large struck the young planet Mercury. It blew the crust off and left behind just the iron core. And the young planet Earth did not escape either.
A planet-sized object slammed into the Earth off-center and blew a huge amount of the Earth's crust into space. The debris circled around the Earth and eventually coalesced to become the Moon.
This demolition derby raged for 500 million years.
What we see now, Mars and Earth and Mercury and Venus, these planets in the inner solar system, they're the survivors. They're the ones who lived through these giant impacts.
Debris from smashed infant planets ended up in the asteroid belt, a junkyard of rocky, leftover planet parts. Most of the big impacts happened in the inner solar system. But one of the outer planets, Uranus, was also hit and knocked on its side. A mystery, since the outer planets formed mostly from gas and largely escaped the violence of the inner solar system.
These rocky cores formed, the gas accumulated around them. This process actually happened very rapidly in astronomical terms, in only about 1 million years. And those are the giant planets we see today.
Beyond the gas giants, Jupiter and Saturn, are Uranus and Neptune. These two are made of gas and ice. And beyond them lies the Kuiper Belt, a band of orbiting icy rocks and dwarf planets. We used to think that one Kuiper Belt object, Pluto, was the 9th planet. We've since decided that Pluto is in fact a dwarf planet, one of many orbiting more than 3 billion miles from the Sun.